Hello everyone, this video is about Numpy. It's a Python library and it is used for multidimensional array and matrix and its various mathematical manipulations of functions. So it is used in variety of domains including astrophysics, biology, chemistry, and sports and many domains. So one of the important use within data science is in deep learning. Uh, it is, for example, it is used in computer vision for image analysis or any sort of image operation. So it uses values of pixels. For example, we can use RGB values of pixels within the image, and we can use it for manipulation and different purpose. So let's get into it. So we have open Jupyter and you can install NumPy using pip install NumPy. So I'm not going to do it because I've already installed it. So let's import NumPy as np. Then to create an array we use np.array and we provide the array within a list. So you can call it this is our array. So let's say we want to make a two-dimensional array. Again, we use np.array and we give it within a list, and again a list of items or data value or whatever you can call. So this is one, and these are the value. So now you'll be able to see rows and columns in the 2D. So this is one row and this is one row. So we have two columns. So we can check that by np.shape. I mean, not np.shape, array 2D, and using a shape function to shape. So you can see that we'll be getting, so we have two rows and three columns. So this is the row and this is the column, right? We can also have a matrix of is just zeros though, and we can also mention the number of rows and columns. So I've taken here 3 rows and 4 columns. So we get all the values to be 0 with 3 rows and 4 columns. So similarly we can do for np dot ones and pass the number of rows and columns. So get all of this with 1 as a value, the items. And we can also use np.I to create identity matrix where you have the diagonal elements all to be the same value. Moving on, we can use something called arrange or arrange. What this does, it gives you a value from the parameter that is passed upon. For example, 1 to 10, which would give you 1 to the 10 values except the 10th value. And let's say you want 2, 4, 6, 8, only these values. What you can do is you can, that is starting from 2, so you can use the step and mention the value from where it has to begin and the maximum length, or not length but the maximum value. So, and the number of steps. So you get from 2 to 10 including 2 steps, get 2, 4, 6, 8. Similarly we can do 3, so 2 plus 3, 5 plus 8, and so on. So between 2 and 10 you can do the same thing for 4 and so on. So this is our range. So let's just keep this as 2. So now we have 4 values. Let's say we assign it to array and we want to reshape this. So we have four values and we want with one row and four columns. Let's say we want to make it two rows and two columns. What we can do is again use the reshape. We can use the reshape. So 2 comma 2, and we get two rows and two columns. We cannot do it in, if let's say we have four values, the kind of rows and column when multiply should give the total number of values within the array. So for example, let's say we have four values here. If we make it like two rows and three columns, we are going to get an error. We can it the total product of the row and column should be equal to the length of the number of items within the list. So 2 comma 2, also if we let's say we have 1 2 3 4 5 6 7 1 2 3 4 5 6 7 8 9, or let's just go with sorry, 1. So we have 12 values here. Now we can give it either, we can reshape it either as two rows, six columns, or four rows, three columns as well. So you can keep it as two rows, six columns, or you can give it as three rows and four columns, or the other way around. So this is how it works. So the number of rows and the number of columns should be the multiplied product of the length of the items within the list. So moving on, so the type of the data. So to understand what type this is, it's called numpy array or numpy.nd array. And moving on to other operations such as, let's say we want to get the of values within an array with a particular condition. Now we have this array, we want only the values with greater than 4. How it works is, when you mention the parameter, you're only going to get initially the boolean values, but when you mention within a list, similar to how pandas works, you're giving a condition. Sorry, last one, this. So yeah, you are getting the values that are more than 4. You're getting all these values considering this particular condition. Moving on, we also have something called linspace. What this does is, you give the minimum value and also the maximum value, and you want your data points to be between these two values, the minimum being 1 and maximum being 10, and you get the value starting from 1 and the maximum 10, and these are the number of items that you get. So all are in the float values. And let's say you want only 4 or 5 values. So similarly, what you can do is you can add another parameter. This will define the number of values. So for example, you can see between 1 and 10 you have 1 2 3 4 4 values that we have mentioned here. So this is about linspace. We can keep it of any number of values as possible. So moving on, we can also, let's say you have, we have array, this is an array, and let's say you want to copy it. So we can do array 4 dot copy. So copy is a method that we can use, and the values will be assigned. Basically the array got assigned to the new variable when passed on using the method copy. We can also to multiply, or let's go with addition. Let's say you have array 1 1 2 3 4, and you have array 2 that is 5, 6, 7, 8. Now you want to add these two. So you can just use the add operator and it will give you the additional output or the output by adding the values. Whereas when you're multiplying, it doesn't work the same way, because if you look at matrix multiplication, you go by row, sum of the row, and I mean row, product of row and column, product of row and column, and you add each value 1 into 10 plus 2 into 20 plus 3 into 30 and so on. So whereas when you try to multiply using the operator, it's giving you an error. Okay, not sure why it's giving an error. It's supposed to. Yeah, it is going to give an error if you are going to have only one dimensional array. So you can see there is only one dimension, right? So the first thing is you need to have two dimensions. So let's create one more np.array of 3 comma 4. This is the first array, and second one being, let's say 5 comma 6, 7 comma 8. Now if we try, so you are going to get a product, but this is wrong. This is not how matrix multiplication works. If you look at it, it's not going through this method, row by column. So what this is doing is it's just multiplying the positions. For example, it's multiplying 5 into 1, giving you 5, and then 6 into 2, giving you 12, 7 into 3, 21. So this is wrong. So this is where dot product comes in. So np dot dot does the matrix multiplication in a proper manner. So you pass the values, and now you can see you get the correct method. So 5, so you have row, and you need to go with the column, right? So you have row and then column. So you have 5 into 1 plus 7, I mean 5 into 1 plus 2 into 7. So like 5 plus 14, 19, and so on. Similarly, it's multiplied. So moving on with the indexing. So let's say we have array 1 and we want to, it works similar to list indexing, you can say somewhere. So this is the 0th index and this is the first index. So when you call array of 0, I mean the array of 0 here is going to get you the 0th index or the first value, which is in this case 1 comma 2. Let's say you want this 2 here. So 0 comma, and again within this 1 is 0 and 2 is 1 in terms of index. So when you give this, you're going to get this value. So one array of 0 is 1 comma 2, and within this again you want this value, so it's 0 1. So this is the 1. So you have to use indexing in this way. Let's say you want to get this value. What are you going to do? You're just going to change this is 0 and this is 1. So you'll change this to 1 and you're going to get this value. And we can also do statistical operations as well. For example, we can get mean, median, minimum, maximum. So let's take an array, np dot array of 1 2 3 4, or let's go with a bit different numbers at least. So these are just random numbers. So ar dot mean, I mean np dot mean would give you the mean value of the particular array that we pass. Similarly, np dot median would give us similarly the median, and to get the minimum we do np dot min and we pass the array, so 2, and also np dot max and we pass the array again. So these are some of the minimum statistical operations that we can do. Moving on, we can also generate random values by given a particular shape that we desire of matrix that we desire. For example, np dot random dot rand, and we pass the size of the matrix, and we also get the random values. So these are very random, and let's say these are float values if you can observe. So if we want more like an integer value, then we can do random dot randint. Here we pass the the range of values that we want, so 1 comma 10, and the size we are looking for. So size will be again a parameter that we'll pass on. So let's see. So yeah, you will get the values. So this is how the random method works within NumPy. So apart from adding and multiplying, we can also find other operations such as square root, exponents and logs, and also even trigonometry such as sine, cos, and tan of. So let's do that. So let's say we have np dot array of 1 comma 4 comma 9 comma and so on. So let's assign this somewhere. Yeah. And now when we do square root, so for square root np dot sqrd is the method, and we pass the array, and we get, so 1 square root is 1, 4 square root is 2, 9 square root is 3, and so on. Similarly, we can do exponential. So this is again, so these are the exponential value, and similarly we can do logarithm as well. So to get log, we pass log, and we pass the array, and we get the logarithm values. So moving on to trigonometry. So let's say we want sine, so we use np dot sine of, let's say we have to pass the arrays again, the parameter, and we are going to get sine of each of these values. So our array was this, so these are the sine value of these particular values. Similarly for cos, similarly for tan. So this is pretty useful, especially if you're dealing with some sort of mathematical operations, which could be useful in the deep learning. Some So moving on, we'll see how we can stack two arrays. Let's say you have array 1 to be like randomly 1, 2, 3, and you have another array that's 4, 5, 6, and you want to join these both, or let's say you want 1, 2, 3 continued by 4, 5, 6 in a single array. So how do you do that is by horizontally stacking. So there's something called horizontal stacking, and the method used is head stack. So you can see that head stack, and we pass the array. So when we do that, okay, 1 second. Yeah, so you can see that the arrays are stacked. So similarly, we can also do something called vertical stacking. So what this does is you want 1 2 3 and the next array again 4 5 6, like 2D matrix. So then we do this. Okay, again the same. So you can see that we are getting a two-dimensional array. So when doing this, we'll have to keep in mind that the number of rows and columns, like especially the number of columns, have to match. For example, we can have, if we have an array which is, for example, 2 3 4 5. So this has four values, right? Let's call this 3. And when we try to vertically stack this and this, so the array 1 and array 3, are probably going to get error. Yeah, you can see that it says as size 3 and the size 4. So that is the problem. So you have to have it in same number of columns. So one more thing what you can do is, let's say you want to split an array. So let's take an array which is, for example, uh, 3 4 5 6 7 8. So yeah, you have an array of 8 values, 1 to 8, and you want to split this. There's something called np dot split, I believe. Yeah, so np dot split, and you pass the array and you mention the number of, you know items that you want, or number of arrays that you're looking for. For example, if you use 2, it'll be split into two arrays, so you get, you know two arrays. 1 to 4 as one array, 5 to 8 as in one more array. So similarly, you can also divide it by 4 here, because we have 8 values. So we have to understand that when we try to split it using an integer, we need to have, if at all, the whole length of items divided by this value should give equal number of items within each array. For example, if we try to divide it by example 5, it's going to say it's not possible. It has to be an equal division. So when we divide it, it has to be the number of items have to be equally divided. So either in this case we can go with 2 or 4. And let's say we want to divide it by 3, and it has to be like 3 elements, then 3 elements, then 3 elements. So now it's possible, since there are 9 items within the list or array. So we say 3, and you can see that it is divided into 3 array, and each array has like 3 items. So this is about splitting. So we can also save this particular array as a CSV as well. So let's import. So yeah, let's import CSV first of all. So after which you can name, let's say new CSV file, and let's name the CSV as new data.csv, and let's give the array to be np dot array of, say, 1 2 3 4. Now what we can do is to save it. So there's something called np.save text. Yes, so we pass parameters such as the name and followed by the array, which is the data, and we use delimiter, so again a parameter, as comma. So So this would have saved the data or the array as a CSV file. So yeah, one more last thing that I would like to talk is something something called NP, something called random choice. So under random, we have choice, and what this does, so equals 10. So what is this going to do is, so we are giving the two variables heads and tails, and we are giving the size of the array to be 10, the number of items within the array. So this is going to randomly provide us with values of heads or tails in 10 choice or 10 items. So, so you can see it's randomly choosing heads or tails with the number of size that's being given. So yeah, I think this is pretty much about NumPy at this point. Of course, you can do other statistical operations as well, like chi-square and so on, which I'll be covering it later in the future. So that's pretty much it about the NumPy library as of now, and thank you so much for watching. Yeah.